Okay, so the last video that I made for the grade 9s, I guess my microphone wasn't working properly, so I'm hoping that we don't run into any more errors like that. So that's too bad. But yeah, like I was saying, if you would like to join the Discord to watch live and then participate with your voice, so if you have any questions or if you'd like to chime in, if I ask you a question, you can do so on Discord, and it's just in the general channel there. So yeah.
But do you have like a name or like I'm just not sure how it works.
Oh, okay, yeah. So for Discord, so Discord is set up into different servers. So the server that I have, you can go to our Google Classroom. I can just find that. So here's Google Classroom. Oops. So if we go to the grade 12 pre-calculus one, I think it was one of the first ones that I posted. Yeah, here it is. So there's an invite link. I know it's hard to read that, but the invite link is just right there, and you can click that, and then you may have to create a Discord account if you don't already have one, but then that will take you to this Discord. It's called a server, Discord server, and then there's all these different little channels that you can join, so you can hop in and out of them. I've kind of tried to categorize them into different categories. So the grade 12 text chat, well, it's looking a little lonely there. But if you guys ever have any sort of general discussion that you'd like to have in the grade 12 channel, you can do that there. If I give you any handouts, I'll put it in the handouts folder. I know it's hard to read, but that says handouts. And then the voice channel, just the general one is just for when I'm live streaming the class.
Okay, thank you.
Yeah. Okay, and I'm really hoping that the YouTube channel is recording my voice. It is?
Yeah.
Oh, okay, cool. How can you tell?
Because I accidentally had my name on one of the live stream.
Oh, there you go. Awesome. So that's great to know. So I will have my volume on. So it looks like no one is on the Discord yet, but yeah, I think we have a few viewers on YouTube. Okay, cool. So anyways, I mean the main thing is you right now. You guys are the ones who are in the room now. So so that's where my attention is. Okay, awesome. Thank you, Riley. Okay, so today we're going to talk about relations, functions, and one-to-one functions. Okay, so that's going to be the topic that we're going to start off with. So I'm going to hope to try to keep this lesson sort of short and sweet. That's sort of the model that I'm trying to sort of achieve here, is to have a short lesson where I kind of give you some ideas of what we're doing, followed by a period of time where you can actually work on some of these questions. So when the lesson is finished, I will be posting a document that has several questions on it, and I'll ask that you do those questions. So it's basically part of a textbook that I've used before. It's a great little book, and I'm just going to give it to you digitally, because that way we don't have to worry about handing back and forth pieces of paper and all that stuff. So let's start off by talking about relations. Okay, can anyone tell me what is a relation? Do we have any ideas of a relation? I mean, even just thinking about the word, what it means in English. So when I think of the word relation, I really like looking at words and taking them apart and looking at the etymology. Etymology means where the word comes from on all the different parts. I like to think of this part, relate. So how many things does it take to relate? Yeah, more than one thing, right? So when you relate something, a relation is a connection between two things. Let me zoom out here so I don't have to keep scrolling. Okay, so a relation is a connection between two things. Okay, it doesn't matter what those two things are. Like maybe you could say that you are related to your sister, right? That would be a relation. In general, like in mathematics, we're often concerned about the relationship between numbers. Okay, so in math, the math idea is two numbers being related to one another in some kind of way. It doesn't really matter how they're related. That's the beauty of it, is that you can make up any relation that you want. So the way we would relate two numbers, well, there's many, many ways that we can relate two numbers, is, well, one way would be just to make a list of all the numbers that you say are related because you want them to be related to one another. So the way we would write this is, well, we could say this is a relation. So we would start off with curly brackets. Okay? Curly brackets indicate that we are making a set. So a set is just a collection of things. It doesn't really matter what we're collecting. It's just a collection of things. They could be numbers, they could be names, they could be anything that you want. So a set is just a collection of things. In this case, we are collecting relationships between two numbers. Okay? Then we would write two numbers separated by a comma in a set of brackets. So let's say we want to relate the numbers 2 and 3. That would say that the number 2 is related to the number 3 just because we said so. Okay, so that would be an example of one relationship. But maybe we want to say that more than those numbers are related. Maybe we want to say the numbers 7 and 36. I don't know, I'm just making numbers up. So now those numbers are related to one another. Okay, let's do another one. Let's try. Oh, I know. How about pi? That's everyone's favorite number, right? And then maybe the square root of 2. Okay, so now we're saying that pi and the square root of 2 are related to one another. And I think that's probably enough relationships for one relation. And this would say, now we're concluding. That is the end of all the numbers we want to have related to one another, and we're done. Okay, so this would be an example of a relation. Okay, just several numbers that are related to one another. So in this case, I would say that 2 and 3 are related. I would say that 7 and 36 are related, and I would say pi is related to the square root of 2. You know what? Actually, I'm going to throw in one more. Sorry for using pen, and now I've screwed up your notes. I'm going to throw in one more just because. So let's say you have a sister, right? But you also have a brother. Just because you're related to one person doesn't mean you can't be related to another person too, right? So just like that, let's say that now 2 is also related to the number 4. Okay, I just wanted to throw that in there just so we can say, oh yeah, well, with a relation, numbers can be related to other numbers too. So you can have as many relationships with numbers as you want. Okay. So I'm actually going to erase this because we're not quite ready. We need a little more room. So don't worry about what I just wrote there. Okay. So another way of writing this, so we could write this. We could write this on a graph. Right? That'll be one way of expressing that same relationship, is by graphing them. Okay. So typically, the first number goes on our x-axis. And our x-axis, which way does that go? Left or right? Left and right, or up and down? Left or right? Up and down. Yeah, it goes left and right. So our x-axis goes left to right. Okay. And our second number, that goes on our y-axis, and that goes up to, I should actually say down to up, down 2 up. Okay, so let's write out this relationship. Let's write out that relation on a graph. Okay, so this is, which one is this? Our x or y axis? Y, thank you. So that is our y axis, and then I will make an x axis over here. And you know what, I'm actually, again, I'm gonna go and sort of change one of these numbers just so that it's easier to graph. I'm gonna change that 36 to a 3, just so it's easier to write down, right? Again, sorry if you're using pen and you have to, you know, scribble that stuff out. My recommendation would be to use a pencil. So let's make this our x-axis. So we've got our x and y-axis. Now what we're going to do is we're going to write down all of these little relationships on a graph. So we can graph these things. So I'm going to use a different color to represent each of these. So this one here, let's start off with the relation 2 and 3. So now we're saying 2 and 3 are related. So the first number we write with our x-axis. So that would be the number 2. So I'm gonna start here. Does anyone know what we like to call this sort of meeting of the axes? Yeah, I like to call this the origin. So just by the way, this point here, 0, 0 is the origin. Just as some vocabulary for you. Anyway, so we're gonna start off at the origin, and then we're gonna move over 2 to the right, and then 3 up. So I'm going to go 1, 2 to the right, and then 3 up, 2, 3. And this would be the point 2, 3. 2, 3, right? So there's the first point in our relation, 2, 3. Then we're going to have another one over here, 7, 3. I should have thrown a few negatives in here, right? But oh well. Doesn't really matter. All of these are going to be sort of in this area because I forgot to throw in some negatives. But you could imagine if we had negatives, we would either have to go left or we would go down. But you get the idea. So 7, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, and then going up 3. So this would be the point 7, 3. And I should start marking these. That's 7, 3. This is 2, 3. We would also have pi in square root of 2. So anyone have like a rough estimation of what pi is? Yeah. 3.14. And then what about the square root of 2? Approximately what's the square root of 2? Like is it more or less than 2? Less than 2. Is it more or less than 1? More. Okay, so somewhere between 1 and 2. What we say halfway about? Square root of 2 is roughly 1.4. Just as a fact, just so you know. Hello. Okay, let me just mark you as here. Just gonna quickly adjust the attendance here. Okay, super. All right. So let's see here. So pi is about 3.14. So 1, 2, 3, and then a little bit more, 1.14. So I'm looking at right around, so 1, 2, 3.14 is like right there. And then the square root of 2 is like 1.4. So maybe like right around there. So I'm going to make that point. And oh, that should be pink. And then this is the relationship of pi and the square root of 2. And then finally, we have one more, 2 and 4, which is going to be right here, 2 and 4. So those are all the points in our relation, okay? Any questions about that? So one way that we can express a relation is by making just a full list. Another way we could do it is by writing down a whole bunch of points on a graph. So this is kind of a visual way. I'm going to show you one more way to express a relation, okay? And this is with a mapping. Okay, so one more way is with a mapping. Okay, so a mapping is where again, it's kind of a visual way. So I'm going to start off with these points here. and they are going to go to these points here. And the way it works is I'm going to write all of the numbers that I start with. These are the numbers that are going to go on the left. So I've got the numbers 2, 7, pi, and 2 again. But I don't want to have to write 2 twice, so I'm just going to leave it at 2, 7, and pi. Okay, so I'll write 2, 7, and pi here. We've got 2, 2, 7, and pi. Okay, and then on the right, I'm going to write all of the numbers that I wind up with. So I've got 3, 3 again, so I'm only going to write 3 once. Square root of 2, and 4. So 3, 3, root 2, and 4. So 3, root 2, and 4. And just to help things out, what I like to do as well is put a little dot on the inside of both sides. And anytime two numbers from our first set and our second set are related, we will connect them with a line. Okay? So I believe that 2 is related to 3, so let's connect that. So 2 is related to 3. Also, 7 is related to 3, so I will do this. 7 is related to 3. Pi is related to the square root of 2. And then finally, the last one is 2 is related to 4. So 2 is related to 4. So that would be the last way of representing a relation. Okay. So those are the 3 main ways that we're going to be thinking of relations. And they're all going to be useful in their own way. Okay. They're all going to be useful in their own way. So again, I tried to give myself little notes to remind myself of what to talk about next, but I guess I don't really need to do that. Okay. So any questions about that before we move on? We good? Okay. What's my time at? That's 17 minutes. That's a lot longer than I was hoping. Okay, I'll try to move along a little bit faster. Okay. So let's think about what a function is. Okay. Has anyone heard that word before? Please tell me someone has heard of a function. Yeah. Okay. So a couple of people have heard of it. If you could define it, you might have to have a bit of a harder time defining it. Hello. So yeah, defining what a function is might be a little bit harder. Let's keep our mask on, all right? Thanks. So yeah, defining a function is a little more tricky, except if we already know what a relation is, then we can use what we know about relations and apply that to our new definition of functions. So a function is a special type of relation. Okay? So a function, it's a special type of relation. What kind of relation is it? Well, it's a type of relation such that any number in the domain, okay, so let's think a little bit about what the domain is. So the domain is the first set of numbers. Okay, so the domain is the first set of numbers. Okay, in other words, this guy right here, this would be the domain. This is the domain here. What about this set of numbers? Do you remember what this is called? The range. Yes, indeed. Okay. So a function is a special type of relation. Any number in the domain, so that first set, is related. Let me go back to pink here. Come on. There we go. Okay, pink is related to exactly one number in the range. Okay, and that is the second set. Okay, so that's what a function is. It's a special type of relation where we only have a single number at a time. Okay, so in this case here, in this mapping, is this relation a function? No, I heard a no. Why not?
Because multiple
Yeah, so this 2 here, this is our culprit. This is our culprit. Because 2 has 2 numbers that it's going to. It's going to both 3 and 4. So that's a concern for us. Okay? What about 3? Is there a problem here? Is it okay that 2 numbers go to 3? Well, let's look at our definition. Any number in the domain is related to exactly one number in the range. So let's see if we can get to the bottom of this. Okay, so let's do a quick example. Is this mapping a function? Okay, so I'm going to make it really easy for us. I shouldn't say easy, but like straightforward. I'm not going to make a super complicated mapping here. So let's do this numbers 1, 2, and 3, and then 1, 2, and 3, and then I'll connect them with their little dots like this. Okay, so I'm going to say that 1 goes to 1. I'm going to say that 2 goes to 2. Then I'm going to throw us off a little bit. I'm going to say that 3 now goes to 2. So is this mapping a function? Yes or no? No. Okay, put your hand up if you believe this function is if you believe this mapping is a function. So hand up if you think it is, like thumbs up. Okay, so we got one hand up. Okay, put your hand up if you think that this mapping is not a function. Okay, so overwhelming majority saying that this is not a function. Well, I hate to say it, this is a function. This is a function. Okay, so let's go over what the definition of a function is. Certainly, this is a relation, right? We have 2 sets of numbers. Some of them are related to some other ones. Okay, but a function is a special type of relation. Any number in the domain, so this number is the domain. This is the domain. This is the range. Okay, so any number in the domain is related to exactly one number in the range. Let's see if that's true. Let's go through every single number in the domain and check to see how many numbers in the range it's related to. So the number 1, how many numbers in the range is this related to? Exactly 1. Yes, indeed. What about the number 2? How many numbers is this related to? Exactly 1. The number 3, how many numbers is this related to? 1. Okay. But I think that some of you are noticing, in fact, the fact that almost everybody had their hand up, we're noticing something fishy is going on here, right? There's got to be some kind of word that describes what's happening here, because there's a number in the range that has 2 numbers related to it, right? So something's going on there. Something's going on there. That is what we would call a one-to-one function. A one-to-one function. Okay? So a one-to-one function is not just a relation, it's a special type of function. Okay? So a one-to-one function, I guess I don't have to write that again. So a one-to-one function, I'll sort of underline it because that's our new definition. A one-to-one function is a special type. It's a special type of function. Okay, and that special type of function we can describe in the following way. Any number in the range in the range is related to exactly one number in the domain. Okay, so keep in mind that it still has to be a function. So it is a function. So it has all of the requirements of being a function, which means that we can't have like two things coming out of the domain. But in addition to that, each one of the numbers in the range can't have more than one number in the domain related to it. Okay, so let's take a look at an example. I keep having to erase that. I'm not going to do that anymore. Okay, so each number in the range has to be mapped to exactly one in the domain. Let's take a look at an example like that. So let's try e.g. Here's a nice little mapping for us. Okay, so I'm going to try again. Let's do 1, 2, 3, and here I'm going to do A, B, and C. Because hey, look, why not use letters? Okay, let's just use letters for fun. So here's our three guys in the range. Here's these three guys in the domain. I'm going to give you an example of a one-to-one mapping. So something like this, something like this, something like this. Okay, so this would be an example of a one-to-one mapping. 1-to-1 function. Sometimes I like to call it a mapping, sometimes I call it a function. It means the same thing. Okay. So we have kind of a hierarchy of relations. So we have these things called relations. Okay. So relations just talk about any type of relationship between two numbers. Yeah.
So I'm sure a one-to-one function also means one number in the domain, one function, right?
Yeah.
Both? Okay.
Yeah, that's why it's called 1-to-1, right? So one of these numbers is going to be mapped to exactly one of these numbers and vice versa. Every one of these numbers is going to be related to exactly one of those numbers. So 1-to-1. So each, you can kind of think, that's why I like this mapping notation, is because you can think about it, okay, it doesn't even matter what's happening over here, right? You can kind of ignore all of that. All you really need to look at is what's happening here. Okay, so there's one little guy coming out of it, right? Here, again, there's only one little line coming out of that dot. There's only one little line coming out of this dot. And same with on this side. Here, I've only got one line coming out of here, one line coming out of here, and one line coming out of there. Okay, so it's a 1-to-1. Okay, so just sort of putting it all together, we have this thing called relations. Okay, so relations just refer to anything where you have two numbers related to one another. After that, we have functions. So functions are a special type of relation. Okay. And after functions, we have relations. Right? You got relations. Oh, sorry, not relation. What am I talking about? What should I have written in there? Yeah, one-to-one functions. And if you want to abbreviate the word functions, this is how you do it. F'(n). That means function. We got one-to-one functions. Okay. So I've got a little bit of homework for you. I'm going to post this on Google Classroom momentarily. Your homework is to do these following problems. And there's also on here, there's like some explanations here if you'd like to review it one more time. So that's the explanations. You can see it's got a lot of the same things that I was talking about. We also have this vertical line test, which I'd like to talk about next class. We got a vertical line test and then a horizontal line test we'll go over that, but I don't want to do this all in one day. Okay, yada, yada, yada. Okay, so I've got this exercise set that I would like you to have completed for next class. So I'd like you to do the following questions. Question 1, question 2. I'm going to leave out question 2E. Don't worry about question 2E. I don't really like that question. And then question 3. Okay, and that's going to be your homework for today. Okay. So tomorrow, what we'll do, so you won't be here, but you'll hopefully be able to log in live, or at least watch the video after it's been archived. What I'd like you to do is, or what I'd like us to do is kind of complete some of these ideas, because we didn't talk too much about graphs and how to recognize functions as graphs or one-to-one functions as a graph. But I'd like to talk about that a little bit tomorrow. And then also, if we have enough time tomorrow, I'd like us to start thinking about ways we can combine functions. So at some point, we're actually going to be doing some arithmetic and some algebra and that kind of thing. But yeah, so I will post this on Google Classroom in about 2 minutes. I'm going to end the video here, which will be the end of the lesson, and you guys can get started on it now. Are there any questions before we jump into it? Have we seen one-to-one functions before? Or is this a brand new topic? Has anyone ever heard of a one-to-one function? No? Okay, so this is new. Great. I know that I didn't talk about it last year. Okay, so that's the end of the video. So I'll end that. Bye-bye.